Please welcome to the stage Elham Tabassi, Chief of Staff of the Information Technology Laboratory at the National Institute of Standards and Technology, as she moderates our first panel of the day on an AI risk management framework.
Hello, good morning, everyone. It's my pleasure and honor to be here and moderate the first session, discussions on AI risk management framework. And grateful for the remarks by Dr. Lacasio. She couldn't give us a better segue to start these discussions. Also, hello to hundreds of attendees that are joining us today virtually, listening and contributing to the discussions today. Let's welcome our distinguished guest panelists today. We have Michael Akinwumi, Chief Tech Equity Officer from National Fair Housing Alliance. Also, Hela Karaju, Assistant Professor, Harvard Business School and Department of Computer Science at Harvard University. And Agus Sudjianto, Executive Vice President and Head of Model Risk at Wells Fargo. Welcome. Thank you very much for joining us for the discussion. Grateful to have you here. This is my first in-person meeting after 2 years of many virtual conversations. Before starting the discussions and our panel conversation, I would like to take a few minutes to set the context and stage for the discussion that follows. As we heard from Dr. Lacasio, NIST has a long standing reputation for cultivating trust in technologies. We do that by participating in development of standards, by advancing measurement science, standards and measurement science that make technology more usable, more secure, more private, more interoperable, in other words, more trustworthy. And we all agree that this is critical in the AI space, particularly given its wide impact on everybody's lives. As we heard from Debsek Graves and Dr. Lacasio, at NIST we have launched an open, collaborative, transparent process for development of a risk management framework that can advance trustworthy and responsible AI. In doing so, the first thing that we needed to do is to understand what constitutes trust. What are the characteristics of trustworthy and responsible AI? In the past 2 or 3 years, we had seen excellent efforts on outlining principles and values that AI systems should exhibit to be trustworthy. Examples are the OECD AI recommendations that the US is a signatory of, along with 40 or so other countries. In the US, we had seen executive orders, OMB, regulatory memo, and agencies such as DoD had come up with their own AI principles. As I mentioned, these documents outlines principles and values for AI systems. And those values and principles includes traditional requirements of accuracy, reliability, being purposeful, accountable, non-discriminatory, and such. But they also stay at a high-level value-based. An opportunity for us, tech and science community, and all of us here, is to translate these principles into practices, translate these high-level value-based statements into requirements that can be designed in developed AI system based on those, but also importantly, test AI system against them. In other words, we want to figure out how to operationalize values. As part of the AI RMF, we have proposed a technical and socio-technical requirements, as we heard. The technical requirements encompass, again, traditional requirements of accuracy, reliability, resilience, and robustness. But we also acknowledge the importance of the socio-technical requirements because at the end of the day, AI is all about context. So socio-technical requirements of privacy, safety, interpretability, and explainability, and mitigation of bias, while also considering guiding principles of fairness, accountability, and transparency. Once we get agreed on the dimensions of the risks or the space of what trustworthiness means, then we need to work on terminology and vocabulary to bring the whole community on a shared understanding of what we mean by each of these words. It's often that we use the same word for different meanings, or we don't completely talk about the full context of that. Examples are, for example, interpretability, what they mean for AI systems, interpretability by whom, to who, and even for terms such as bias. A lot of community, a good portion of the community use bias as bias in data and algorithm. And the document that we put out about a month ago expand that definitions to include other aspects such as systemic bias. What I tried to do by that effort is to provide a shared vocabulary lexicon to communicate about AI risks and AI trustworthy, so we can all be on the same page. Beyond knowing the characteristic of the AI systems, it's really important to know how to measure them. You cannot improve it if you cannot measure it. That's a quote from Lord Kelvin that's very dear and near to many of us working at NIST. The importance of the TEV, test evaluation, verification, validation cannot be underestimated. And the good news is that disciplines such as software engineering have been using verification validations forever, and there are good examples to build on top of that. AI systems today, some of them are not going through the thorough evaluations and validation that they ought to be. Once the risks are identified and measured, their magnitude and impact, positive or negative, is understood, then a risk management based on those informations and impact can help to maximize the benefits and minimize the risk to individuals, societies, and organizations. The message here is that there is no one-size-fits-all. The risk threshold, the risk appetite is going to be different based on the use case, based on the context, and that needs to be done on case basis by the owner of the applications. And of course, a culture of risk management along with the right and appropriate policy and procedures are needed to ensure that the risk and potential impacts are identified, tracked, measured, and managed. So I just gave you a sort of overview of the AI risk management draft that's out for public comment until the end of this week. We envision AI RMF, as Dr. Lacasio mentioned, to be a resource center of documents, standard tools, guidance that helps individuals, society, and organizations on how to map, measure, manage, and govern AI risks. As part of the map function, context is recognized and risks related to context are identified. Measure provides guidance on how to assess, analyze, track identified risks. The goal of manage is that the risks are prioritized and acted upon based on projected impact, and govern promotes a culture of risk management, a culture of understanding, communicating, and managing AI risks. So with that context, let me turn to our distinguished guests and panelists, and let's start the panel by maybe we can go around and do a very short introduction. So how about we start with you, Michael?
Yeah, thank you, Elham, for walking us through what NIST is doing with the risk management framework. So I'm Michael Akinwumi from the National Fair Housing Alliance, the nation's only civil rights organization that is dedicated to eliminating any forms of discrimination or segregation in housing systems, including the use of algorithms to find evidence of discrimination in housing systems. So I lead the tech equity team at the organization, and the team is dedicated to doing just 3 things. The very first one is education. So we not only educate policymakers, advocates, different advocacy groups about the benefits of AI and why they should be part of conversations around promoting the benefits, but we also educate model developers, the data scientists, about the histories, the legacies behind the data, so that they could look beyond the data and focus on how to invent or innovate different techniques to mitigate the risks that are baked into the data. And the second thing we do is research. So we research into different techniques for promoting algorithmic fairness and also mitigating risks that may be associated with machine learning systems or algorithmic systems. And another thing we do is enforcement. So we work with different enforcement groups in the event that we find evidence that algorithms or algorithmic systems in general are actually discriminatory. So we work with them to go through the process of identifying these bias or discrimination that are baked into the algorithms, and then they could use that evidence to eventually seek for relief and justice for any members of the communities that are discriminated against by use of algorithms in housing systems. And thanks a lot for inviting me, for having energetic and rich conversations about how we can actually mitigate risks that come with machine learning systems, while also improving or providing access to members of our nation that may be left behind if thoughtful processes are not in place to make sure that we mitigate this risk.
Excellent. Educate, research, enforce for a more inclusive economic growth.
That's right.
Perfect. Hema, can you please go ahead and introduce yourself?
Thanks so much again for having me here. I'm excited to be here with all of you. I'm Hela Karaju. I'm an assistant professor at Harvard University with appointments in the Business School and Department of Computer Science. I primarily work on this broad area of trustworthy machine learning. So more specifically, I do research in this area and also think quite a bit about the practical and ethical implications of AI tools as we produce them at large scale these days, right? More specifically, my work focuses on developing new methods and theory to better understand machine learning models or explain them or interpret them, and also to make these models more fair and also robust. So the sort of the keywords that I work on are interpretability, explainability, fairness, and robustness. And more recently, I've also started thinking a lot more about privacy and more specifically differential privacy as another focus area of research. Excited to be here again, and thanks so much for having me.
Thank you, Hema. Everything we need to build a foundation for developing rights-preserving technologies. So a lot to discuss there. Agus, please go ahead.
Thank you for the opportunity, Elham. My name is Agus Sudjianto. I'm the head of model risk for Wells Fargo. My responsibility is overseeing models and model development before they put in production, as well as they are in production. When they are in production, as financial institutions like banks run by models. So we have a couple thousand of them in production today. So we have to manage the risk because we believe all models are wrong. And when they're wrong, they create harm and damage to the user, to the institution, and to the society. We have very mature and disciplined practice, as well as the my peer banks, the large banks in particular, have since the 2008 crisis have very well established nowadays the practice of managing model risk, which come very, very handy with the explosion of AI and machine learning, because we have practicing this as day-to-day discipline how to manage model risk.
Extremely important activities, and I'm really excited to the discussion. So let's dig in. I'm gonna point my questions, call on you, but please feel free to react to each other's remarks. Michael, let's start with you and ask you to please expand on what you said in your introductory remark about how you're using AI. We're interested to hear how it has, its positive impacts. You alluded to the issue of the bias and non-discriminatory, extremely important when we want to hear examples or what you're doing, but also has it helped and how you do or if you're doing cost-benefit analysis every time that you want to use an AI system to figure out the positive or negative consequences and it should be used or not.
All right, thanks for that question, Ella. So I'm going to start first with the benefits in terms of what we do at the National Fair Housing Alliance. So one thing that we've extensively talked about, is the dual credit system that we have in America, right? So, and what that means, especially for people of color, is when you look at the credit scoring systems, which is also one of the systems that power our housing system, is that the data could actually exclude especially members of people of color communities. And from my own previous experience and what we also do currently at the National Fair Housing Alliance is we see that AI or machine learning systems actually hold a lot of promises, especially when we leverage alternative data to make sure that we have inclusive credit scoring system. And that's one of the many benefits when it comes to using AI or machine learning system to improve access to credit and also housing. Now, when it comes to our works or focus on risks that may be associated with AI or machine learning systems, earlier on I talked about the history behind the policies that generate some of the data that drive our housing systems, right? And having worked, and I still work as a data scientist, usually the focus is on the data. We're not really thoughtful or careful about really understanding the processes that generate or generated the data. So what we do is that we look into frameworks that could really guide our model developers into understanding the processes that generate the data, right? Because usually when you want to develop a models, an algorithmic system, what you do is you start with the data. But we are actually starting way before that, because if you think of the process of becoming a homeowner, so one of the very first starting stages is the pre-qualification stage, right? And then you go into underwriting and lending and all that, right? So we focus on understanding the actual policies and the history behind the data, and then also paying attention to understanding how whatever business problems that are being used to drive the housing systems, how they're actually contextualized or represented in the data, and also looking into different ways where algorithms are being used to actually implement these problems that are represented in the data. For example, there is a lot of works that we have done in terms of the discriminatory impact of the pricing systems that we have when it comes to home ownership. So we're looking into algorithms that are being used to decide what the terms and conditions of mortgage loans should be. And also when it comes to advertisement, right? So there are a lot of algorithms that actually oppress or suppress what is presented to people who are trying to become homeowners. So we also look into how either intentionally or otherwise, some of these advertisement algorithms could be selectively biased in terms of what they recommend or present to people who are either looking for rent opportunities or rent solutions or looking for housing opportunities. So that's really what we do. And looking at both sides, the benefits and also the risks, we try to find a way where we can actually have a middle ground to make sure that we don't allow the risk to stop us from actually innovating some of the algorithmic solutions that are being used in housing systems.
So continuous monitoring of positives and negatives across the life cycle to maximize benefits and minimize risks. That's perfect.
Right. Yeah,
a lot to unpack there, but go ahead, Hima.
Yeah, I just wanted to underscore one of the points that Michael just mentioned, which is, I think, and also which is one of the key characteristics of the risk management framework put out by NIST. I think it's very important to think about this as a risk and benefit analysis, as opposed to sort of finding a risk and then thinking of it as, oh, this tool has some risk, so maybe we shouldn't even innovate here, right? Or do anything about it. So I think Michael nicely articulated that point, that we consider both sides of the picture and then look at AI systems more holistically. So I think it's great that we are kind of highlighting that point of thinking about this as a risk-benefit analysis problem here.
Excellent. Now that you're on, can I also ask you to say how the research you do on advancing the interpretability help with some of the bias issues that Michael talked about? Does it help, and we all often heard that there is a trade-off between all of these technical and socio-technical that we put out. Tell us about interpretability, its relationship to bias, and what it means really, and how we're going to assess that.
Yeah. No, that's a very deep and broad question, so I'll try my best to shed some light on it here. So I work, as Elham mentioned, on this area of interpretability/explainability. So essentially, the idea here is to give some reliable information about models to different kinds of stakeholders, right? So whether it is people within the company, data scientists themselves who are building the models, or managerial folks in the managerial positions who are trying to make decisions about whether these models should be deployed or not, or the end users that these models are impacting, how can we think about providing reliable understanding of what the model is doing that can be helpful to different stakeholders, right? So ultimately, that's what is, I think, the core underlying principle. And I think this notion of interpretability is, I think it's so complex because it is often sort of determined by who is at the receiving end of it, right? Is it a developer, engineer, researcher who can understand machine learning well? If so, the kind of interpretability we would provide would be much more different for them, right? Compared to somebody who is like a doctor or a loan officer who is at the receiving end of trying to understand the model, in which case how you would explain these things to them would be different. So given the complexity in the number and also the diversity of the stakeholders, the notion of interpretability can mean very different things depending on who you're thinking about, right? And I'll just give some quick examples about like how interpretability can be thought of in each of these contexts. So for example, if we are thinking about a developer and linking this to the question of bias that Elham is also interested in talking about a bit more. So let's say there is a developer and the person has built a model, and now of course they've done their usual metric measurement of measuring accuracy and so on, but essentially if they can, let's say, get an insight into what are the important or key features that the model is focusing on when making predictions, right? So either for individual predictions or for smaller groups of predictions, that can help them realize if the model is using some spurious features or irrelevant features when making predictions, right? So there's a classic example of people sort of making predictions about what sort of animals are in pictures, and this is often given as like a poster example for explaining why interpretability could be important. Either you look at the different features in the face or the eyes of the animal and then determine, oh, this animal is a cat versus it's a Siberian husky. Or you could look at the background of the image. For example, maybe look at snow and determine if the animal is Siberian husky or not, right? So are we building a snow detector or not? Or are we building a detector that focuses on the facial characteristics of the animal when doing so, or when determining what animal is in the picture? So that understanding can be provided if we tell the developer or show them or highlight them areas within this image that the model might be focusing on, right? So that is a kind of, one way of thinking about helping developers, engineers, the builders of these tools to diagnose undesirable biases in these systems, right? And a completely different way of thinking about explanations is, let's say you have a person, a loan applicant, whose loan application has been denied by an AI or a machine learning model. Instead of just telling them, oh, sorry, the model thinks your application should not be approved at this point, if we can give more inputs into what are the features that this person should actually go on and change in their profile before they reapply for a loan so that they can successfully obtain a loan, that's a different kind of understanding which is helping a different stakeholder, right? And in each of these kinds of understandings, you can see that when we provide that understanding, if there are any, and biases does not always have to be about like racial or gender, though they are of course the predominant biases that we worry about, they could just be something like the model is using irrelevant features when making predictions for one group in the data versus the other, right? And that deeper understanding that goes beyond just the statistical checks of fairness that we could do over the model can be provided by interpretability or understanding of the model.
Excellent, that was a great...
If I could just, I really like the point you mentioned about I mean, the use case you mentioned about loan application, right? So where once in the event that your application was actually declined, as a consumer, you should have the right to know what you need to do, say in 3-6 months when you come back to actually be qualified for that loan, right? But one of the things I like to say when it comes to different techniques, explainability, interpretability, and different attributes is, all models are wrong and some are useful. So when it comes to interpretability and explainability, they are still based on assumptions, right? And I also think for us to actually continue to build trust in AI or machine learning systems, it's also important that we're transparent about the assumptions behind this interpretability. Because, for example, when it comes to some of the policymakers or even an average consumer, we don't want them to think that because this model is interpretable, it's explainable, then they should not ask questions about the assumptions that are baked into that model. So thanks for...
No, I completely agree with that. I think clearly stating the assumptions that are being made when we give out an explanation is very critical. And one more point I would like to add there is the goal of interpretability is not to build trust in the model. I would think of it as the goal of interpretability is to build apt amount of trust in the model, right? So in some sense, if the model is not trustworthy, interpretability should help you realize that. It's not always about sort of making a case for the model. It could also be about making a case from not using the model, right? So that's how I would think about it.
Let's bring Agus in discussions, and all this are extremely important, and we call them core building blocks that gets us towards trustworthy AI. But without having governance and policy and procedures in place, we can't really achieve the goal of the trustworthiness. Objective expert review feedback are staple of scientific progress and essential in building confidence. You are a leader in development of formal governance for AI and models, and a very excellent track record of how to implement that. So tell us about formal governance, the role of that on making sure that measuring bias and interpretability, all of these things actually happens.
Thank you, Elham, for that question. Let me probably step back a little bit in terms of the importance of governance, in particular, the practice and the discipline that we had in the financial institution, particularly for large banks. We have been practicing in the, how to manage, how to govern this in the more than 10 years now, since the inception of SR 11.7 and OCC 11-12. So some of you that are not familiar with that, please Google and study that very important document that the OCC and Federal Reserve published back then, post the 2008 financial crisis. I would like to highlight a few things that very, very important in that relate to NIST RMF. One of the things that in the NIST RMF that has a paragraph about accountability. That is super, super important, and start with the accountability at the board level and the senior management. I would like to go one more step on that, because that's the practice what makes it successful in terms of establishing governance and process, is the independence and stature. In bank, a particular large bank, they designate very senior leader as the head of model risk. Today, probably in the AI world, people call it head of responsible AI. So I'm one of that. Every bank has people that at my position. I report to the chief risk officer, and chief risk officer directly report to the board. And notice that I report to the chief risk officer. I don't report to the business leader. I don't report to the head of technology. This is an independent function. Two in the company that directly report to the board to do this. The head of model risk management set up policy, procedure, role and responsibility, accountability in the business. Who need to own the model risk and how to manage model risk in that. Including on the model development, the process of model development, the documentation, the testing and the documentation, and then the usage of model appropriately in the business. So that is very, very critical. And part of that, the model risk management group in the company, in banks, it's a very serious thing, because I give you an example. For us, every 3 model developer, we have 1 model validator, very seasoned, and in our team, 90% of the model validator hold PhD degree. So every 3 model developer has 1 independent model validator. The model validation report to me, they don't report to the business. So this team, this independent model validator, has the authority and stature. The head of model validation is at the same level as the head of model development in the company. For us, we have 7 model development in the company. We have 4 head of model validation. And the model validation has the authority and stature to approve or reject model, to challenge the design and the use of the model. And for large banks like Wells Fargo or JP Morgan or Bank of America, that's people with the size of more than 300 people in the model risk management. So this is a very, very serious thing. I would challenge, if we want to make this one work, the other industry, particularly critical industry like healthcare and all of life science and healthcare, they need to commit in terms of the right use, the right governance, and have real teeth. At the end of the year, I have the authority to challenge the individual, the model user and model developer, their performance rating. And we have influence to alter and to challenge, to override how their rating based on how they manage model risk that impact their compensation. And I would like to bring a little bit as well, when we talk about model validation, to challenge in terms of model design. And I want to relate a little bit to what's in the RMF in NIST, particularly the socio-technical aspect. Right now, the socio-technical aspect, which include interpretability and explainability, include the privacy, include the safety, and also fairness. Yes, it is perception of the people that subject it, but these 4 components need to be designed in, cannot be done after the fact. And we have problem today by treating that after the fact. We build a model, and then we assess the socio-technical aspect. That will be too late. I give an example, a few things that may resonate to you. Recommender system today, the damage that recommender system done to the society divide in the society, and the misinformation, and the implosion of misinformation, because recommender system on the socio-technical aspect is looked at after the fact, instead of designing recommender system that will avoid that. Large language model today. People build large language model with data, large data, whatever, and throw it into a black box model. The damage of large language model on the discrimination, the model that's very discriminatory, racist, is in there, because people don't look at it, design in all the socio-technical aspect. And I'll bring it something that very close and near and dear my heart. Credit underwriting. The design in interpretability in the credit underwriting. And I'm going to say it out loud here. The use of post hoc explainability on credit underwriting is a treatment of after the fact. After you build the model, I am trying to explain the model. I think it's something wrong that we need to question there. We need to design in the interpretability in the model itself. And we have tools that, for that. A lot of my peers working on this. Scott Soldi from FICO doing the latent representation in the neural network to design in interpretability, inherent interpretability in the model. Rich Caruana from Microsoft has EVM, explainable boosting machine, to design interpretability in the model. Cynthia Rudin from Duke, building a rule-based system to design in interpretability in the model. I myself and my team, we work on the putting structure and constraint on the deep neural network so that it can be inherently interpretable. So this is something that I want to make a plea, particularly to the field of what we call XAI today, that 95% talk about post-hoc explainability, treating explainability and interpretability after the fact. We need to shift the focus for the academia and the practitioner to really on the critical aspect like this. Please design in socio-technical aspect of this. Don't treat it after the fact.
Yeah, if I could just add, so in terms of like the socio-technical guiding principles from the risk management framework, I actually agree with you that it shouldn't be after the fact, because by then the damage is probably already done, right? And that's why the framework that we have at the National Fair Housing Alliance for auditing algorithmic systems actually takes that into consideration. So we have a framework that we call PPM, Purpose, Process, and Monitoring. So the purpose section actually takes all these socio-technical guiding principles into consideration. Now, I'd like to add to your excellent, great comment about model validation. So when I look at the model lifecycle system that is in the risk management framework, so I always say that the journey actually begins after deployment, right? So if you have model validators, right? So you have your training data that actually, or test data that was used to validate the model. So I also hope that we pay due attention to monitoring the model once it is deployed, because that's where we get cues about when to rebuild, retrain, or possibly retire the models after it's deployed. So thanks for sharing your thought.
Yeah, that's really important. And in the AI risk management framework, we emphasize the importance of study, understand consequences from the, all across the AI lifecycle, starting with design. And that's what I mean by operationalizing values, instead of after the thought trying to assess if they are, as you said, private enough, safe enough, non-biased enough, rather than put them from the get-go into the design. And I really like this framing of rights-preserving technologies. So we are really trying through the whole work of the AI program, Trustworthy Responsible AI program at NIST, to not necessarily shift the viewpoint, but expand the viewpoint that rather than focusing on the technical, traditional technical characteristics of accuracy, reliability, robustness, bring the socio-technicals from the get-go. And of course, it brings its own challenges because we don't quite know how exactly assess for many of these socio-technical requirements. Agus, that was excellent. You answered a lot of, it kind of gets us to the next round of questions that I wanted to ask, but which are about, do we have enough standards, tools, guidance today? There's a lot that we can use and leverage, but do they have the right AI angle? And that's why also AI risk management framework come in. But Hema, let me bring you back into the discussions. And I think before start thinking about building these tools and standards and frameworks, we want them all to be technically sound, scientifically valid. So from the research side, do you think we are ready, or what type of research or gaps exist to do exactly what Agus said, to operationalize these values and get these discussions from at the design stage, rather than worry later on to assess for existence of those trustworthiness?
Right. Yeah, I mean, in all these fields, whether we talk about, the field of fairness or robustness or interpretability or, post hoc explainability or, just kind of any of these aspects or privacy, right? So there is a lot of research work already out there. And by that, I mean, there are several methods to achieve them. Different methods are focusing on different kinds of use cases or stakeholders. So I think there is a sort of a critical mass in terms of the body of literature. That said, with every new class of models we develop, there are new challenges that arise, right? Like, for example, GPT-3 came in, which brought in a new set of challenges about how to rethink all of these aspects all over again, right? Now there is DALL-E, and that will itself bring another new set of challenges to think about. So I think this is almost like, while we have some intuitions into how to think about these notions, they're also going to constantly evolve as the field itself changes, right? So that's one of the reasons why we may not always be in a position to plan for everything like during the design phase itself. Like, for example, you might discover a few things, of course, like I think I completely agree with Agus's point and what Elham also said and what's in the NIST risk management framework document, that it's definitely something that we can't treat as an afterthought. We should start thinking about it right from day one as we start building these models. But at the same time, just from a practical, logistical perspective, there would always be things that even with the best of intention, you may not cover or check off right in the beginning and might have to be addressed at the end, right? So I think my answer to that question, do we have all the research in place to attack these problems? Yes, these fields are rich with work, but again, the problems that emerge will also change, and we need to constantly keep the field of research evolving. So yeah, that's what I would say. There is one aspect though, which I think also builds on some of the points that Agus and Michael made earlier, which is as we start thinking about these different pieces right from the beginning of model development, something that even from the research perspective is currently lacking, as well as also is not thought of enough even at the beginning or even as a post hoc thing after the model has been developed, is the trade-offs between different aspects that we have, right? So for example, by making a model interpretable, you are probably exposing it to some privacy risks. Or by improving the fairness in certain cases, you might be taking a bit of a hit in accuracy or private. I think the trade-offs of these things are not very well understood yet, even in terms of research. I think that's where we need to put a lot more effort into. So that would be like my one take in terms of what the research community can do better, apart from just kind of being on its toes and constantly adapting to the new sets of problems or challenges that arise across all these aspects. So, yeah.
So what I'm hearing from you, Hema, and stuff that Agus and you, Michael, said, we need a tight coordination among a very diverse team of people that know how to build models, which is usually computer scientists and mathematicians, but also people can think about the impact and consequence of that, which is usually cognitive scientists, sociologists.
And also, if I may just add, even I think within computer scientists, usually a bunch of people deal with interpretability, another bunch deal with like privacy and so on. But I think there should be more coordination even among those so that we understand the trade-offs and risks better. Otherwise, each person is adding a piece that is somehow affecting the other and we don't know why and how.
So the question for Agus and Michael, that you are doing it in some sort of operational everyday, how do you handle that? How do you address that? Tell us about your diverse team.
I can share a few things our practice today. So we have very, very standardized in terms of standard how people need to develop model and document it. So we have model development template that people use in terms of giving for different class of model, basically. And all of those start with very, very fundamental question, which you probably call it a socio-technical, we call it model risk. What can go wrong with the model? So people need to be able to answer with that. First, with the intended use of the model. What can go wrong when the model is wrong or create unintended harm? What are they, and how much is acceptable in terms of risk appetite? And how are you going to measure it? Start from that. And then from that, they need to document the model choice of model specification, the choice of modeling approach, and the testing as well. What are the testing that need to do? So that is very, very well documented. And I'm just going to, and documentation standard in banking, we have very, very high standard, the requirement in terms of if somebody, independent model validator, and can pick up the document, they can understand the model, they can replicate the model, and they can challenge the model just by looking at the document. So that model documentation, it really put the expectation standard, how people develop model. And this is going beyond what people call model card today or system card today that's out there. It's really detailed document. Some of my peers here from financial institution can testify this. I give an example in terms of the rigor of that. When we do stress testing, and every year we do stress testing in bank mandated by regulation, we use roughly about 500 models to stress every aspect of the bank. So 500 models, and we submit the documentation to Federal Reserve and OCC. If we count model development document and model validation document, which is the mirror image of model development, but from independent assessment, with those 500 models, it can easily go to 150,000 pages documentation. So I challenge you in practice out there. If you want to be serious in terms of standard, this is the level of documentation and approach that we need to do. And part of that is not the challenge that people will put on there. Building machine learning model is not simply running AutoML. AutoML, and particularly with machine learning, because it's very, very notorious with machine learning. So many parameters and so many hyperparameters. So you can have many, many models that will perform very, very similarly when you do testing. They are very similar. That's the problem with AutoML today. So you need to choose, you need to design model that conceptually sound, and you test it, because model that you pick, you choose, you test based on testing data. And the world changed when we use the model. The world changed, the distribution shift. Model that perform the best, Kaggle competition style, you put it in production, the robustness with the distribution change shifting, it crumbled. And what's the result of that? Machine learning people will calibrate, will retrain the model every 3 months, every 6 months to refit the noise. So that's the problem with the practice today. That's what we're trying to avoid in any of how we operationalize this. We need to build model that are resilient, that is robust, that we call it risk invariance under different environment. So we codify that in our approach and in practice today.
If I could just add to your question about how to operationalize some key elements of the framework. So I would say that we also need some guidance, especially when you think of, I always call the framework M3G, like map, measure, and manage, right? And then governance. Right. Now, on the measure part, right? So my co-panelists actually mentioned, if you probably have 10 computer scientists to measure fairness or accuracy, they're probably going to come up with different metrics, right? So that's why we look for, we look up to organizations like NIST to provide guidance on how these metrics, what metrics should actually be used to measure or quantify risk. For example, one of the things I say, especially when I look at housing data, is maybe you don't want to use accuracy to actually quantify the performance of the model that you develop, because we know that the data itself is tainted. It does not represent, all the profiles that should be represented. For example, looking at credit data, we have a whole large population that are either not visible in the credit data or probably unscorable in the data. So without guidance on what metrics should be used, for example, to measure fairness or even to quantify privacy standards that we have, then leaving it up to data scientists or computer scientists to decide what they use will probably still amplify the risk that we're trying to mitigate. And I also like to say, when it comes to this documentation, like Dr. Agus actually mentioned, it's really great that Wells Fargo and all these financial institutions are doing a great job of providing thorough documentation, because that's what we actually need to really assess some of these risks that we're talking about. So I would just say, in addition to model development documentation and model validation documentation, in line with what Dr. Agus said, that the environment is dynamic, it keeps changing, that I'll also advocate for needs for model monitoring documentation. So we should not leave it up to the same team that develops the model and puts it into production to monitor, for example, the drift in the models they've deployed. So we should also call for documentation about how they monitor the models that they have in production, because that's how we can actually mitigate or eliminate harms that some of these models may be causing to consumers.
This is a great discussion, and if I can summarize it, importance of clear roles and responsibility, importance of accountability across the line, importance of documentation to avoid minimizing everything into a checklist that you make it a yes, no. To do all of these things, we do need the right metrics. So we spend a lot of time understanding what it is to measure. Now we need to be able to have interoperable metrics and methodologies for tests, because as you said, Michael, the result of tests can look very different if we don't use standard metrics. At the same time, also acknowledging that coming up with metrics, particularly for socio-technical parts, is a sort of a bleeding edge research, and as we heard from Dr. Lacasio, requires new thinking in measurement, new thinking in standards. We, as many of you know, as part of the AI RMF, we are also building a companion document to provide more detailed, practical guidance about all of these things. So what does established context mean? What does testing mean? What metrics? But also, more importantly, what data to use to do testing. So we welcome all the discussions. These are really great input to us, and look forward to continuing these discussions as we develop the AI RMF. Looking at the clock, I can't believe that we are down to the last 10 minutes, so I'm going to jump to the closing questions, and I think I'd like to hear your thoughts about two things. One, about one thing that we ought to do and we are not doing at all today, or we are not doing enough of that today, and also your vision where we ought to be in 3, 5, or 10 years from now. So we have all these great discussions about operationalizing values, and it looks like that we are all on the same page. There's also a lot of challenges to actually reach that. We have a lot of really good examples. So Hema, maybe we start with you. Like, tell us about one thing that we ought to be doing today that we are not doing or not doing enough, and your vision for future.
Yeah. So I think, as I was mentioning earlier, so there is, I think, a lot of sort of, here are 10 different metrics to measure fairness, or like here are 30 different algorithms to achieve interpretability, but there is not enough work that is being done on which to use when, right? So which metrics to rely on, under what settings, what circumstances, what kinds of questions, which algorithms to rely on, again, what settings, what context, what kind of, answering what kinds of questions. I think there should be more emphasis on characterization of the current, whether you want to call it research or literature or practices. I think that's not being done enough, right? So, and I think this would also answer, like, or rather point to some of the things that Michael was discussing, which is that I think we should definitely try and concretize how to measure reliability, or like how to, model robustness into the models and so on. But there are, among several tons of methods that are out there, which methods work under what conditions, of the data, of the dynamism of the environment, that is not very well understood. I think that needs to be sort of thought of a lot more. And the second thing I want to say is, again, just touching upon these kinds of trade-offs between the different measures, I think that there is not enough discussion happening on that. Everybody wants all the good things. We all want privacy. We all want interpretability. We all want robustness. But these things come with trade-offs where providing one means like sort of reducing the emphasis on others. So what does an application need? What can we afford to provide in terms of these trade-offs for different applications? I think that needs to be thought out a lot more. And the third thing I want to highlight is I also see this kind of our tendency to quickly label things as, oh, don't use this, don't do that. I think that is probably, in my humble opinion, I think that is probably, I think we should always approach things with a certain level of curiosity and say, can this work in certain circumstances? Can this actually be beneficial in certain circumstances? As opposed to, I think, quickly labeling whether it's tools, models, metrics, or methods as this good, this bad. Because usually I think a lot of what we have in AI, just like humans, is gray. Some of it is good, some of it is bad. It may work wonders in certain contexts, and it may be the absolute worst thing in certain contexts, right? I think kind of encouraging dialogue around nuances more than labeling things is extremely critical today, especially today more than anywhere, any other time in history, I would say.
I'll summarize that by saying that we need to excite, energize, invigorate innovation ecosystem to come up with all these answers to all these questions. But if I may rephrase one of the things that you said, instead of can we use, and going back to what Agus was saying, thinking about should we. So it's not only about being able to build these things, but should we. Michael, get your thought about one thing that we ought to be doing today that we are not, and where do you think we should be? Where is your vision for 3 to 5 years? Or maybe 10 years?
Since I joined the responsible AI community, right? So I begin to see data differently. So I actually see data as a representation of real human stories, right? And even working with the National Fair Housing Alliance, that actually opened my eyes to the policies and processes that generate this data. For some of us that have a quanta background, you always think of generative models, your statistical processes that generate the model. And I keep thinking that one thing that we need to be doing to really see the human stories behind this data is to facilitate dialogue, conversations, between or among different stakeholders that are trying to put these algorithmic systems into use. For example, we've seen instances where arguments around the risk and benefit of AI or machine learning are often framed as a struggle or a contest between technologies who are trying to maximize profits and consumer advocates who are trying to make sure that risks are minimized, right? But then the more we have dialogue, we can actually see that we're trying to solve the same problem, but from different angles or different perspectives. So one thing that I think we should start doing is what is already demonstrated by the National Fair Housing Alliance, which is a traditional advocacy group giving somebody like me an opportunity, coming from a pure data science or math background, to join that struggle. And I think many other organizations, financial institutions, can actually leverage from that by bringing in people who actually have domain knowledge about the issues, the underlying issues, the context that was actually raised in the framework about the data, so that they are part of the development process. Perfect. So that's one thing. In addition to that, I'm going to use the opportunity to also restate the need to monitor these creations that we put in production.
I want to also make sure that Agus gets some time to final thoughts and as looking at the clock, close the discussion for us.
Well, I think NIST can do a big service that I mentioned before, putting the socio-technical aspect into design in, to be explicitly say that, because today in the document it's very silent and seems to sound after the fact. So I think it will be huge contribution of NIST if can put the socio-technical aspect as a design requirement. Secondly, is something that I'm very happy to hear from NIST in the framework that we don't practice today and many don't practice today, that we need to do more. We talk about robustness, we talk about reliability, we talk about resiliency. The practice today in machine learning, a lot of data science, big model that perform the best based on testing data. That is very misleading, and that causing all the myth and the thinking about trade-off that we have to have between accuracy and robustness and so on and so forth. But if you're thinking about the use of model in the context, we cannot just simply based on the metrics model that perform the best based on testing data like in Kaggle. Then all of a sudden the myth and the concept of trade-off disappear, because we need to design model that is robust, that reliable, still reliable when distribution shift, and resilience. So I think that practice, I'm hoping that with NIST really pushing the idea, we will shift away the culture from Kaggle culture of chasing the last drop on the performance, really building model that really will work in the real world.
Yes, instead of focusing only on accuracy, think about if it works, who is left out, what are the impacts, what can be done with that. With that final thought, and only 30 seconds into the session, thank you so very much for the discussions. And with that, let's thank our speakers.